All right, today we are talking about compounding n times a year throughout a time period. So this is very much like the same formula. We have P, we have our R, we have our time, we have our ending value. But the difference is this N here. Here and here we have N. N represents the number of times that the money is compounded throughout the year. That means we're adding that interest on early, basically. And they don't give you the full interest, so they cut up the rate. And because it's compounded a different amount of time, you have to increase the amount of time you run the formula, basically. So when you use this formula, the key to knowing that it's this formula is that you have an interest rate that's compounded a different amount of time. So usually this is an annual interest rate, and then it's compounded one of these times that are coming. So the formula is the same. So for example, the formula in this case would be A of t equals the starting amount, which was 1,000, times 1 plus, it's always plus for this formula, the rate, which in this case, the rate is 0.075. Now, the difference is, and then there's a t. The difference is here, the n has to be put here and here. And the n is told to you, you know what the number is, by how many times per year this, whatever the word is. So in this case, annual, that's once a year. So that would make this guy 1. Okay, so this one, and then each one of these kind of increases the number of times per year. So semi-annually would be 2 times a year. So that takes this formula, the exact same formula, and now we have a 2 down here. Okay, so I'm going to pause this for a second and kind of fill these in and then just focus on the how many times per year. Okay. All right, so I wrote this formula for all the exact same ones. Okay, they're all exactly the same. Now, the only thing that changes is this number and this number are your n values. So you actually write n twice. So for quarterly, well, how many quarters are in a dollar? 4. So that means I divide up the rate by 4 and I increase 4 times. How many times I run that? Okay. And then monthly, so that's how many months are in a year. Most of these are pretty logical, so hopefully you understand that. So there's 12 months in a year, so we put a 12 here and here. Weekly, not many people know weekly, but weekly is 52. That's the same as cards in a deck. And so in a deck of cards, there are 52 cards. There's 52 weeks in a year. So you put 52 here and here. And daily is 365, approximately. We do have leap years sometimes. Okay, beautiful. So the formula is very similar to the one that we did yesterday. It's always plus. And the number of times per year is just put in those 2 spots. All right, so to do a couple problems like this, or one problem like this, using this formula. All right, we are using this formula, so let's get used to using it. Molly invests $8,700, so our P value is $8,700. And she's got a 3% interest rate, annual interest rate. So that's the R. So we always take that 3%. Move the decimal place over 2, so it's 0.03. Our N value is how many times per year. So monthly is 12 times a year. So now write a function M of t. So if they say M of t, make sure you use M of t instead of A of t. And write the formula. So the first thing we put is 8,700. That's our starting value. Then it's 1 plus the rate, divided by 12 to the 12t power. Okay, so remember this 12 and this 12 are the same 12 from here. Determine to the nearest cent how much money Molly will have for her son after 18 years. So this problem is in years. It's annual interest rate. So we plug in T is 18. So it's the same exact thing that we have here. We're just replacing the T. So M of 18 is equal to 8,700. You can figure out what this number is. I think it's, let's just fix that. 1.0025. So all I did was take this, put it in my calculator, and that's that. So it's just a little easier to write. And then 12, and T is 8. Plug that in. Oh, it should be M. Let's fake that. And we get $14,919. So remember, the nearest cent is 2 decimal places, or to the nearest hundredth. So it goes right to here. So our rounding will just be this. Okay. Beautiful. In what year will Molly's investment have doubled? Whenever they talk about when will it be doubled, they're always talking about the original investment. Okay, they're never talking this one, right? The answer to the above problem. They're always talking about the original investment. So if I double 8,700, I get 17,400, and that's my ending value. This is now going to be my M of T. Okay, for this one, we need to figure out what T is. So T is going to be the one that doesn't have an answer yet, or it doesn't have something to plug it in. That's what we're trying to find. So since we're solving for an exponent, so that means that I'm going to have to use logs. So whenever you see that, remember, oh yeah, I got to use logs. This is a thinking bubble. You know that logs are going to be needed. So process is similar to what we did yesterday. Divide by 8,700. You're going to get 2 here because we're doubling. And then we get 1.0025 to the 12t. Okay, this one has one extra step, but the next step is the same. So this is the moment we're using logs. This is my base. So logs, the base. Oh, I put an S. That's hilarious. Sorry, erase that. I can't. Okay, I got this. There we go. So the subscript here is the base, which is 1.0025. The other box here is this, 2, and that equals 12t. So we're going to figure out this number, and then our extra piece is we have to divide by 12. So remember, it's alpha window 5 to get to we can put the base in, and we get 23.13 is your t. So in Molly's, when he's 23 years old, her son will have doubled the money. She will have doubled her money. All right. I hope you understand, and we'll talk tomorrow. Have a great day.